Let's answer the question, do all systems have one solution? Not all systems of linear equations have a single solution as the examples before. Some systems have no solution and some have an infinite number of solutions. Remember, the standard form is ax plus by is equal to c, and the slope is found by dividing negative a over b, and the y-intercept is found by dividing c over b. So let's bring our first equation, that is 3x minus 5y is equal to 20. Then the value of a is 3. The value of b is negative 5, and the value for c is 20. Let's find our y-intercept, and we do that by dividing c over b. So that becomes 20 divided by negative 5. Well, 20 divided by 5 is 4, and because I have different signs, this is negative 4. So let's plot the y-intercept on the y-axis, and that will be located at negative 4. Next, we look for the slope so that we can find a second or third point. Remember, the more points, the more precise our graph is going to be. And we do that by negative a over b. Well, a is positive 3, but because of the negative in the formula, this becomes negative 3 over negative 5. And even though we cannot divide or simplify 3 over 5, the negative will make this a positive 3 over 5. That means that our rise is 3, so we're going to move 3 up, and our run is 5, so we're going to move 5 to the right because they're both positive. So that makes it 1, 2, 3 up, and then 1, 2, 3, 4, 5, and that's where we plot our next point. Now, you could have left the 3 over 5 as negative 3 over 5. That means that we will have a rise of negative 3, so we will go 3 down, and a run of negative 5, so then we will go 5 to the left. If we plot that point 3 down, remember from the y-intercept, and then 5 to the left, we will end up with the same line when we connect all 3 points. So let's do that. Let's graph this line. Once we have our first equation graphed, we're going to bring the second. So this is 6x minus 10y is equal to negative 10. And we find our a, that's 6, our b, that is minus 10, and our c, that's also minus 10. We begin by finding the y-intercept by dividing c over b. That will be negative 10 over negative 10. That's equal to 1 when we make the division. And then the slope is found by doing negative a over b. So that will give us negative 6 over negative 10. Now the negative will make this slope positive, but not only that, we can also simplify this fraction by 2. And that will give us 3 over 5. So doing this again, let's plot our y-intercept first at 1. And then use the slope to find our next point. So this will be 3 on the rise, so that is 3 up, and 5 on the run, so that will be 5 to the right. Let's do that. From the y-intercept, we will go 3 up, 1, 2, and 3, and then a run of 5. 1, 2, 3, 4, 5, and that's where we plot our second point. Now, just like at the beginning, did we actually have to simplify? No, we can use the original slope. That means that if you have a rise of negative 6, we're going to go 6 down. And if we have a run of negative 10, we're going to do 10 to the left here. So 6 down, that would be 1, 2, 3, 4, 5, 6 down, and 10 to the left. That would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And that's where we will plot our point. Now, the only thing about leaving it without simplification is that the numbers could be too big to fit, at least in the graph that I am using. So it's up to you. If it fits, then just use it without simplification. But if it doesn't, you might want to simplify. So let's plot this second line. When we finish graphing our second equation, you're going to notice that our lines are parallel and they never going to meet. Now remember, the solution is where the lines intersect. So since they're never going to meet, they're never going to intersect, we're never going to be able to find a solution. Then that means that this system has no solution. Could we have seen that this system had no solution without having to graph? Yes. If you watch the video on parallel lines, you might remember that parallel lines have the same slope and different y-intercept. So because both of our equations have the same slope and different y-intercept, we would have known that the system had no solution without graphing. Let's try another example. I'm going to write the standard form, and the slope is found by doing negative a over b, and the y-intercept is found by dividing c over b. Now you might be asking, why do I continue to write the standard form in the formulas to find the slope and the y-intercept? Well, it's always good practice that every time you do an example that you write down the formulas so that when the exam shows up, you will remember which formulas to use. So let's bring down our first equation. Our A is 8. Our B is minus 4. And our C is at 12. Let's find the y-intercept by dividing c over b, and that is 12 over negative 4. So 12 divided by 4 is 3, and the different signs will make that negative 3. So that is my y-intercept. I'm going to plot it in the y-axis. Next, I find the slope, and that is negative a over b. This is negative 8 over negative 4. And 8 divided by 4 is 2, and the negative will make that positive. But remember, since we need a rise over run, I'm going to make this whole number a fraction by dividing by 1. This means that I'm going to have a rise of 2, so I'm going to move 2 up, and a run of 1. So I'm going to move 1 to the right. So from my y-intercept, I move 2 up and 1 to the right. And I'm going to do it one more time. 2 up and 1 to the right. So now I have 2 points. Remember, the more points you plot, the more precise your graph will be. So let's graph this line. Now, we're not done. Remember, we still need to bring our second equation, that is 14x minus 7y is equal to 21. And we find our A to be 14, our B to be that minus 7, and our C to be 21. We look for the y-intercept, and that is C over B. That's 21 over negative 7. And 21 divided by 7 is 3, and the difference in signs will give us negative 3. So we plot our y-intercept at negative 3. Oh, look at that. It falls in the same place as the previous one. Let's look for the slope then. Our slope is negative a over b. That's negative 14 over negative 7. Well, 14 divided by 7 is 2, and the negative will make it positive. And if I write that as a fraction, that is 2 over 1, that means that our rise will be 2, so I'll go 2 up, and our run will be 1, so I move 1 to the right. But when I do that, I'm going to notice that my next point, 2 up and 1 to the right, is going to fall in the same place as the first equation. And if I do it again, 2 up and 1 to the side, our third point continues to fall on top of the first equation. So if we graph this second equation, the second graph lands right on top of the first one. That means that these two equations represent the same line. They intersect at every single point. So if I select this point, that point is in both the blue and the green. If I select this point is also on the blue and the green. If I select this point down here, it's also on the blue and the green. That means that this system will have infinitely many solutions. Let's write that. Infinitely many solutions. Now, could we have seen that this was going to happen without graphing? Well, yes. If you go back to the first equation, the slope was 2 and the y-intercept was -3. On our second equation, the slope is also 2 and the y-intercept is -3. So because they have the same slope and the same y-intercept, that would mean that if we graph them, one line will land on top of the other, giving us infinitely many solutions. Using the substitution method, how do we find when the lines are parallel and there is no solution, or when you end up with the same line and you have an infinitely number of solutions? We were going to start just as before. I'm going to select one of the equations. Okay, so I have 6x minus 10y is equal to -10. And this sum I'm going to solve for y, so then I'm going to move the 6x to the other side, and I do that by subtracting 6x. Remember, we move anything that is being added or subtracted first. So from left to right, 6x minus 6x will go to 0, leaving us with minus 10y equals. And on the right side, remember, these are not like terms. I'm going to put the x first and then the number second. We are not done. Remember, we still need to remove that multiplication by -10, and we do that by dividing every single term by -10. From left to right, -10 divided by -10, that's 1y, or just y. On the right side, 6 cannot be divided by 10, but it can be simplified. Both of these can be simplified by 2, leaving me with 3 over 5x. And because they're both negatives, that will be a positive 3 over 5x. And then the last term, -10 divided by -10. Well, 10 divided by 10 is 1. And because, again, they're both negatives, that will be a positive 1. So that means when we go to step 2, we're going to replace this y with 3 over 5x plus 1. So let's go to step 2. In step 2, we bring the remaining equation, the one that we did not use in step 1. So this is 3x minus 5y is equal to 20. And I'm going to replace the y with that 3 over 5x plus 1. And we bring down the rest. Before it, I have that 3x with the minus 5 multiplying, and on the right side after the y, I have equals to 20. Don't forget, parentheses is king, so I'm going to multiply. Let me do it on the side. Let's multiply the numbers and deal with the signs later. So I have 5 times 3 over 5. Remember, in this case, the 5s are going to eliminate each other, leaving you only with that numerator of 3. So then I have from left to right, I have the 3x, And then this 5 times 3 over 5 gave us a 3. Don't forget, this one has an x. In the minus positive different signs, the result will be negative. We continue to multiply. I have minus 5 times 1. Well, anything times 1 will give you back the same thing. So this is minus 5 is equal to 20. No fractions, but we do have like terms. I have 3x minus 3x. Well, 3x minus 3x, 3 minus 3 will go to 0. This gets eliminated, leaving you only with minus 5 on the left side and a 20 on the right side. And minus 5 is not the same as 20. Notice how all our variables disappear and we ended up with a false statement. You might be asking, why is it false? Well, because the left side does not have the same value as the right side. It's like saying that owing $5 is the same as having $20. And I don't think that's correct, at least not last time I went to the bank. So because all the variables disappear and you end up with a false statement, that means that this system has no solution. That means that this system, if you were to graph them, these are parallel lines. So this is how you know when you have no solutions. I'm going to repeat it again. If your variables, you see how we don't have any x's or y's? If your variables get eliminated completely and you end up with a false statement because the left side does not equal the right side, that means that the system has no solution, because if you were to graph these, your lines will be parallel. Let's try another example. So I'm going to go to step 1 and I'm going to select the first equation. So this will be 14x minus 7y is equal to 21. And I'm going to solve for x because why not? Since in the previous one we solved for y, let's do x this time. So if I'm going to solve for x, I need to move this 14 and this minus 7y. Remember, first we move anything that is being added or subtracted. So since the 7y is being subtracted, I'm going to add both sides plus 7y. Okay? So this will leave me from left to right with a 14x. Now minus 7y plus 7y, different signs we subtract. So this goes to 0 because 7 minus 7 is 0. And on the right side, I have the 21 with a 7y. Remember, these are not like terms. We cannot combine them. We have to write them as separate terms. I'm going to write the 21 and then the y second. Now, because this x is being multiplied by 14, every single one of these terms is going to be divided by 14. Very carefully here. 14 divided by 14 will be 1x, or just x, equals, well, 21 cannot be divided by 14 evenly, but they both can be divided by 7. They can be simplified by 7. So that will give me 3 over 2. And then the next term, I cannot divide 7 by 14 evenly, but again, they can both be simplified by 7. So 7 divided by 7 will be 1, and 14 divided by 7 will be 2. Don't lose the plus and the y, and we have completed step 1. Let's move to step 2. We bring the remaining equation, that will be the second one, 8x minus 4y is equals to 12. And we're going to replace this time the x with 3 over 2 plus 1 over 2y. So right here where the x is, I'm going to write 3 over 2 plus 1 over 2y. And then I bring down the rest. There is an 8 before the x, and then all of this after. Parentheses is king, so I'm going to multiply. Let's do it on the side. This is 8 times 3 over 2. Now, there are different methods that you can use to multiply, but I'm going to do the shortcut, which is we multiply the numerator and then divide the denominator. So 8 times 3 will be 24, divided by 2, that will be 12. So then we begin from left to right as 12. Now I still have to multiply this 8 times a half. So 8 times a half, we multiply the numerator and divide the denominator. 8 times 1 is 8, divided by 2 is 4. So that will give us then a 4. There's a plus, and don't forget the y. Bring down the rest. 4y is equal to 12. There are no fractions, so we can combine like terms. In this case, 4y minus 4y. Well, 4 minus 4 is going to give me 0, leaving me a 12 on the left side and a 12 on the right side. Now, because the left side equals the right side, this is a true statement. What does that mean for us? Well, on the previous example, if you got a false statement, that means that it was no solution because your lines were parallel. In this case, since all the variables disappear again, but I end up with a true statement, the left side is equal to the right side, this means that the system has infinitely many solutions. So then what happens if you were to graph the system? It means that these are the same line. One equation will land on top of the other. But if we're using the addition elimination method, how do we find when we have a parallel and no solution, or we find that they are the same line and they have infinitely many solutions? Well, we're going to start just as before. We're going to go through the steps. First, we're going to line up the variables. And we see that these are already lined up. I have my x's, my y's, and then the equal sign. So now I'm going to have to select one of the variables to eliminate by cross multiplication to create opposite coefficients. Now notice that this time the x's have the same sign and the y's have the same sign. So what I'm going to do is I'm just going to select to eliminate the x. Since this time the signs are not opposite, I don't have a preferred variable to eliminate. So I'm going to eliminate the x's. That means that the first equation is going to get multiplied by 6 because that is the coefficient of the second x, and that's the variable I decided to eliminate. And then I'm going to multiply the second one by 3. And I'm going to have to do an extra step. Because the x's have the same sign again, and they have to be opposite in sign, I'm going to make one of these a negative, either the 6 or the 3. It doesn't really matter which one it is, so I'm going to select the second one to be the negative. If you want to select the first, you can pause this video, go and multiply the first equation by -6 and continue the steps and see if you end up with the same solution as I do. So this time I'm going to make the 3 the negative. Okay, so let's multiply. I have 6 times 3, that's going to be 18x's. And then 6 times -5, that's going to be -30y's. And then I multiply 6 times that 20, that's going to equal to 120. We try the same equation. So 3 times 6 will be 18x's. But since one is a +6 and the other one is a -3, different signs, this will be -18. And then I have -3 times -10. Well, 3 times 10 will be 30y. And the negative will make this positive, equals -3 times -10. And that's going to give us +30. Okay, so we have selected a variable to eliminate and we cross multiplied to create opposite coefficients. Now we need to combine the resulting equations. When I combine the resulting equations from left to right, +18 and -18, we subtract. So 18 minus 18 will go to 0. And then I have negative 30 and positive 30. Different signs, we subtract. So 30 minus 30 will also be 0. So we ended up with everything being eliminated on the left side. So I have nothing left on the left side. Now on the right side, I have 120 and 30. Same sign, we add, and that gives me 150. Notice how this time both variables, the x's and the y's, got eliminated. So I cannot continue to solve the new equation. I don't have any variables left. What I do have is a 0 on the left and a 150 on the right side. Well, this is not true. 0 does not equal to 150. 0 is not the same as 150. So I end up with a false statement. What does that mean for us? Since all the variables got eliminated and I end up with a false statement, that means that the system has no solution. I wasn't able to solve for the variable and I end up with a false statement. So this is no solution. What that means for us is if we were to graph these equations will be parallel. Let's try another example. I'm going to go through the steps. I'm going to make sure that the variables are lined up, and they are. I have x's and y's and then the equal sign. Then I'm going to select a variable to eliminate by cross multiplication, making sure that I create opposite coefficients, one positive, one negative. So I'm going to eliminate the y's this time. So if I eliminate the y's this time, that means that the first equation is going to get multiplied by that 7, and that the second equation is going to get multiplied by that 4. Because I need to create opposite coefficients, we're going to need to make one of these a negative. This time, I'm going to make the first one a negative. So let's start multiplying here. See what we get as a result. So I multiply negative 7 times 8. 7 times 8 is 56. Different signs, I will make it negative 56. Don't forget the x. 7 times 4, that is 28. Y, and because they're both negatives, this will be positive 28. Don't lose the equal sign. And then negative 7 times 12, that will be negative 84. Let's try multiplying the second equation. 4 times 14, that will be 56x. 4 times negative 7, that's going to be negative 28y. Don't lose the equal sign. And 4 times 21, that's going to give us 84. So we have completed step 1 and step 2. We move to step 3, and that is to combine and then solve the equation. So when I combine from left to right, you see here, I have a minus 56 and positive 56. Different signs we subtract, so 56 minus 56 will go to 0. Then for the y's, I have a positive 28 and a negative 28. Different signs we subtract, 28 minus 28 will go to 0. That means that we're left with nothing on the left side. That's 0. There's nothing left on the left side. Let's try the right side. I have negative 84 and positive 84. Again, different signs. We subtract, so 84 minus 84, that also goes to 0. So what happens again in this situation is that both the x's and the y's got eliminated, but this time the value of the left side is the same as the value on the right side. This is a true statement. 0 is equal to 0. So what this means for us is that this system has infinitely many solutions. If we were to graph them, that means that these are the same graph, the same line. One line will land on top of the other. if you graph the linear equations and they intersect at one point, then you have one solution. For the substitution method means that we were able to find a value for x and y. The next type of solution is the no solution. When graphing, that means that the lines were parallel and they never intersected. In the substitution method, it means that both x and y got eliminated and what remained was a false statement. That means that the left side did not equal the right side. Now the third and final type of solution is the infinitely many solutions. That means that when we graph them, one line landed on top of each other. For the substitution method, it means that both the x and y got eliminated and what remained was a true statement. That means that the left side equal the right side. Thank you so much for watching, and I'll see you in the next one.